Hello, this is Dr. Amudapriya, Associate Professor Tripoli, Rohini College of Engineering and Technology. Here we are discussing about the course Power System Operation and Control, in which we are going to discuss about the dynamic programming model in this lecture. So, in dynamic programming method, the unit commitment table is to be arrived for a complete load cycle. What are the advantages is, in this case, if a strict priority order is being imposed, the number of combinations will be a good one. For example, if we are considering 4 units, then we could have the priority of 1 unit, or the first and second one, the first, second and third one, and the first, second, third and fourth one. Likewise, in priority wise, it can be easily listed. So, what is the main advantages? Reduction in the dimensionality of the problem, that is the number of combinations that is to be tried will be considerably reduced. So while considering the priority listing, it can be used only if no load costs are 0, unit input output characteristics are linear between the 0 output and the full load condition, that is no load and full load condition. The phase shifting transformer tap position is good, and when switch to capacitor settings are being considered, and then reactive power injection with the static VAR compensator is done, and during load shedding and in a DC line flow. So regarding the assumptions, the total number of units available, their individual cost characteristics and the load cycle on the station are assumed previously. A state consists of an array of units with specified units which are operating and the rest offline. The startup cost of a unit is independent of the time it has been offline, that is a fixed amount. So there are no costs for shutting down a unit, and there is a strict priority order, and in each interval a specified minimum amount of capacity must be operating. While considering the forward dynamic programming method, the algorithm it has to run forward in time from the initial hour to the final hour. So the forward dynamic programming is suitable if the startup cost of the unit is a function of the time, that is it has been offline, fixed amount. Previous history of the unit can be computed at each stage and compared, and initial conditions can also be easily specified in this case. For example, we'll start with the step-by-step algorithm. One could set up a dynamic programming algorithm to run backward in time starting from the final hour to be studied back to the initial hour. Conversely, one could set up the algorithm to run forward in time from the initial hour to the final hour. The forward approach has distinct advantages in solving the generator unit commitment. For example, if the startup cost of a unit is a function of the time it has been offline, then a forward dynamic program approach is more suitable since the previous history can be computed at each stage. There are practical reasons for going forward. The initial conditions are easily being specified and the computations go forward in time as long as required, and the forward dynamic programming algorithm can be easily enabled with the recursive algorithm in order to compute the minimum cost of operation. So this is how the cost is being, forward cost is being framed, and the transition cost is being framed, and how the new variables and the number of strategies are being considered for the complete enumeration. And this is the neural structure, which is the initial stage and the hidden stage and the final stage, after which we are getting the output. This is the algorithmic process which are being executed in case of a dynamic programming model with the starting as an iterative process in order to obtain an optimal schedule with a lower cost.